We will begin today with another review exercise. So get your speed drill and review exercise booklets out. Turn to page 7, and we're going to do exercise number 7. Page 7, review exercise number 7. And in our last exercise, you'll recall we had the formula, speed is equal to distance divided by time. Well, if we wanted to talk on that same note, but we wanted to solve for distance, distance is equal to speed times time. Or as it says there in the bold at the top, the distance an object travels is equal to the product of an object's speed and the amount of time the object travels. Distance equals speed times time. It is important, though, that the time component of speed, whether it be miles per hour or feet per second, must match the unit of time. So hours or seconds. So in order to multiply miles per hour by time, you have to have hours. For feet per second, you'd have to have seconds. Does that make sense? All right, we've got just 6 of these for you here in exercise 7. Go and get started finding the distance traveled in each case. When you finish, pencil down, look this way so I know that you are finished. Try to ignore the howlings from downstairs. I think it's our K3 students. tearing up the road. That's good.
Hmm?
There's that spot where the road had that little random sink, and they're tearing it up so they can fix it and level it off. That makes sense. Right. Yep, of course. Bye, Lexi. Pretty good.
I just can't figure something.
All right, let's take a look at these together. Pencils down even if you're not finished. Hayden was first. Hayden, how far would someone travel if they traveled 45 miles an hour for 3 hours?
135 miles.
135 miles. You just multiply 45 times 3. How about 608 miles per hour for 1 3/4 hours?
1,064 miles.
Good. You could either change that to a 7/4 times 608, do some canceling, or you could do 1.75 times the 608 to get 1,064 miles. What if an object is traveling at 68 feet per second for 75 seconds?
5,100 feet.
5,100 feet is correct. How about 12 feet per second for 4.5 seconds?
54 feet.
54 feet. Here's a fun one. What about 75 miles per hour for 30 minutes?
37.5 miles.
Good. We're going to have to change 30 minutes to what?
0.5.
Half an hour, or 0.5 hours. Then we multiply the 0.5 times the 75, or the 1/2 times the 75 to get 37.5 miles, or 37.5 miles. Great job. And then for the candy, the last one, if an object travels 37 feet per second for 3 minutes.
6,660 feet.
6,660 feet. Again, we're going to have to change the 3 minutes into 180 seconds before we do the multiplication. Great job there. 6,660 feet is correct. Anyone else get them all correct, just not as fast as Hayden? Anyone just miss one of the ones you did? All right, any questions on those? Do they make sense now? I talked through the 2 hard ones at the bottom. Any questions? All right, let me go and collect those from you. Take your textbooks out. Page 108. Take your textbooks out and turn to page 108. You did the homework at the bottom of page 108, numbers 1 through 8. Also on page 109, you did numbers 17 to 21 and 38 to 40. So books open to page 108, and let's take a look at the homework that you did. So basically the blue problems on the page 109, and then the 1 through 8 at the bottom of page. Did you do these on paper by any chance?
I think so.
Okay, get it out quickly. And those should have been pretty easy to do in your book, frankly. And then those are on paper. Thank you. All right, they're on paper. Good. She is finding it. Good.
Is that it? Or
Should be a 1 through 8. But that looks very close because that's something we did in class yesterday. So what's on the next page?
it's not on the next page.
Uh-oh. Tell you what, Lexi, we'll let you answer 1 through 8 orally for us. So, 2 rules, class, that we needed to remember, and they're over here where the camera can't see, but I'm too lazy to move it. For adding assigned numbers, class, if the signs are the same,
Add and keep the signs.
good, it's literally as easy as reading it, okay? If the signs are the same, class,
Add and keep the signs.
add and keep the signs. So now people on video who couldn't read it a minute ago can answer with us. If the signs are the same, add and keep the sign. And then if the signs are different, class, subtract and choose the sign of the greater absolute value. Again, if the signs are different, subtract and choose the sign of the greater absolute value. So for those watching on video, now that they know what it is, or they've found it in their notes, if the signs are different, subtract and choose the sign of the greater absolute value. All right, so on number 1, Lexi, do we add or subtract?
You subtract.
Because the signs are different, so we get
3.
3. And what sign do we keep?
The positive.
We choose the positive there, positive 3. For number 2, add or subtract?
Subtract.
To get
2.
and keep the
Positive.
positive 2. Number 3, we
Add. We subtract.
To get
-1.
1, and then we're going to keep the negative. So -1. Number 4.
You add and keep
Add
the
to get
-6.
6, and then we're going to keep the negative sign, -6. Number 5, what do we call those numbers, class? Inverses. And inverses always
0.
cancel to give us a 0. So number 5, we should have 0. Again, signs are different, so we subtract to get 0. We're supposed to keep the sign of the greater absolute value. Well, which of those numbers has a greater absolute value?
Same.
Neither of them. They're the same, so you don't keep either sign because 0 is neither positive nor negative. Back to Lexi, number 6. What do we get?
-5.
Keep the sign of the greater value.
Oh, +5.
Positive 5. How about number 7, Lexi?
-7.
-7. And then what about number 8?
-4.
-4, because we add and keep the sign there on 8. How many got all of those correct? 1 through 8. Questions on adding signed numbers. All right, look across the page, page 109. And what property is being illustrated on number 17? Evie? Associative. How about number 18, Glenn? Commutative. How about number 19, Aubrey? Distributive. Number 20, Danielle? Commutative. And number 21, Michael? Distributive property. Coming down to numbers 38 to 40, we had to do a long division problem. Let's see what Hayden got.
562.
That is correct. How many also got 562? All right, keep working on that division. For sake of time, I won't show it now, but if you want some help, come see me after class. If you're watching on YouTube, like, I still struggle with division, I'll video chat with you. Just let me know via email. Number 39, multiplication. It's a big one. What do we get for our answer? Let's come back to Lexi.
I forgot about my comma. 53,527.
Ooh, really close. Aubrey?
I got 113,377.
Oh my. Glenn?
535,027.
535,027. How many got that answer on 39? Okay, just a few of you. All right, again, if you need help, see me after class, and we'll go over it then. Again, if we have time at the end of the video, I may come back to these just as we're a refresher. And then number 40, keep that decimal lined up as we add all those money amounts. And what do we get for our answer on that one? Let's go back to Aubrey.
143.29.
But since it's money, we would read it.
$143.29.
There we go. $143.29 is correct. How many got that answer for number 40? All right, all of us got that one correct. So a division and multiplication, again, lots of little places. And I know with some speed drills, we've had some struggles with that as well. So again, if we have time at the end of the hour, we'll go over that together. Yes, ma'am.
I think I really like my answer for 39 wrong. What was the answer?
535,027. Yep. All right. Flip back, if you would, to page 105. Flip back in your books, if you would, to page 105. We talked yesterday about adding signed numbers. I want to talk to you today about subtracting signed numbers. Don't write anything in your books just yet, but I want you to consider this. 5 minus 2. Now you could say, well, that looks like 5, -2, or positive 5, -2. But if I were to write it this way, it becomes clear that I mean positive 5 minus positive 2, right? Well, you know from, like, kindergarten that 5 minus 2 equals 3, right? And if we were to show this on the number line, for sake of, being a bit excessive, if we will, if we were to start at 5, subtraction doesn't go this way because subtraction doesn't make numbers bigger. What does subtraction do? Makes them smaller. Subtraction is going to go this way. So when I subtract 2, I have to go backward 2, and that's where we get the answer positive 3, because I go backward 2 on the number line, right? Well, what if I had positive 5 minus -2? Well, in this case, class, subtraction says I'm supposed to go what way? Backward. But a negative sign always goes the opposite direction, right? Addition goes this way unless you're adding a negative. Then it goes this way, it reverses course. So if subtraction is supposed to go this way, then if you subtract a negative, it's going to reverse course and go this way, and we're going to get an answer of 7. If I were to have, say, a -3 plus or minus a positive 4, for instance. Well, again, we would start class at the -3, and subtraction says we go backward, right? This way, 4 units. 1, 2, 3, 4 is going to put us where? At -7. But if I had, say, a -3 minus a -4, 4. Well, again, subtraction says to go this way, but if I subtract a negative, I have to go that way. And so I end up going 1, 2, 3, 4 this way, and I end up at positive 1. Well, in each case, subtracting a positive goes backward just like adding a negative. And if we were to say, well, let's subtract, keep the sign of the greater, I'd get a positive 3. Subtracting the negative ends up going forward, which would be the same as adding a positive, which if you just add and keep the signs, you get the 7. If I were to subtract a positive 4, it's the same as adding the negative 4. I still go backwards and add and keep the sign, get a negative 7, right? Or subtracting a negative 4 is no different than adding a positive 4 and subtract, keep the sign of the greater opposite, I get a positive 1. Do you see that? So what you see in your textbooks there in bold, it says, to subtract signed numbers, express the subtraction problem as addition problem by changing both the operation and the sign of the subtrahend. That's really annoying. I want you to write this on the side of your books. Subtraction is adding the inverse. Subtraction is adding the inverse. Just write that there in the side margin or the top. Subtraction is adding the inverse. So when it comes to signed numbers, we're never going to, quote, subtract. If we see a subtraction problem, we're going to change it to an addition problem. And the beauty of that class is, you know those 2 rules you mastered yesterday and handled really, really well? We're going to do the same stuff today. So today is no harder. We just have to go through and change anything that says subtract to addition. And anything that has, and whatever sign comes after it, also changes. Look at the little blue shaded box there on page 105. It says 4 minus 8, which could be read positive 4 minus positive 8. Or we're going to change our subtraction class to addition plus, and we're going to change our positive to a negative. 4 plus negative 8, which would give us, of course, negative 4. If we have a 2 minus a negative 6, we never really subtract class, we add the inverse class. What do? Add the inverse. So it says subtract. I'm like, no, I ain't doing that. I'm not going to subtract. I'm going to add the inverse. I'm going to change this to addition. I'm going to change this to a positive. And now I've got a positive 2 plus a positive 6 gives positive 8. Add and keep the sign. Look at the next one. If I have a negative 1 minus a 5, or what's an understood positive 5? Well, I don't really subtract. I add the inverse. I'm going to change this to adding a negative 5. Or the better way is just to look at it as negative 1, negative 5, which is what I taught you yesterday. They're both negative, right? Rather than thinking of it as a subtraction, think of it as just adding a negative 1, negative 5 gives
6.
Negative 6. Adding, keep the sign. Look at the examples at the bottom of page 105 as well. They have a negative 2 minus a positive 4. No. We don't do that. We're going to change it to negative 2 plus negative 4. And then they use the number line. Nah. We're just going to go negative 2, negative 4 gives?
6.
Negative 6. Add and keep the sign. Look at the next one. 5 minus negative 1. No. Not 5 minus, 5 plus, and instead of a negative 1, positive 1. Well, we know what 5 plus 1 is. 6. There's our answer. Questions on that? Easy enough? Look at page 107. Page 107. Numbers 9 through 12, they have 4 subtraction problems. In the little bit of space right below numbers 9 through 12, I want you to rewrite each of those as an addition problem. Not trying to insult anyone's intelligence here, but you know. So rewrite each of those 9 through 12 as an addition problem instead of as a subtraction problem. Number 9 says negative 2 minus positive 8. We don't do that here. How should we rewrite it, Michael?
Negative 2 plus negative 8.
Negative 2 plus negative 8. Number 10, it says 5 minus positive 6. Nope, not in my house. What are we going to do instead, Aubrey?
5 plus negative 6.
5 plus negative 6. Number 11, 9 minus negative 6. No. Danielle?
We're going to do 9 plus positive 6.
9 plus positive 6. Number 12, negative 6 minus negative 3. Nope. Evie?
Negative 6 plus positive 3.
Negative 6 plus positive 3. Make sense? By the way, now that we've rewritten them, number 9, what would we get, class? Negative 10. Add and keep the sign. Don't forget to keep the sign. Number 10, what would we get? Negative 1. Subtract, keep the sign of the greater absolute value. Number 11, what would we get?
15.
Positive 15, or just 15. Add and keep the sign. How about number 12? Negative 3. Subtract, keep the sign of the greater absolute value. I want you to do numbers 13 through 16, but we're not going to use the number line. We're too lazy. So just change it to adding the inverse and write the answer. You can skip the number line thing. Ain't nobody got time for that.
1 through 6.
Just 13 through 16.
Yeah.
The 4 number line problems, but we're not going to use the number line because we're too lazy. When you're smart, you can be lazy. But never do, right? That's shore. Shore. Like pull for the shore, sailor, pull for the shore. Kyla's like, no, Nadaski's doing it now too. Sorry, Kyla. Lexi's like, sorry, not sorry.
No, she hears it enough. She's good.
Pretty sure she does.
It's mean.
Bless her heart. We love you, Kyla.
Which one?
What?
There's 2 different ways to say that.
Huh?
I'm saying there's 2 different meanings to that.
Yeah, well, I'll leave that to her imagination. And yours. Number 13. We rewrite it. What do we get for our answer, Michael?
Negative 8.
Uh-oh. We have a 1, which is a positive 1, correct? And then we have to, it says minus a positive 7. No, we're going to change it to
Addition.
plus a,
Negative 7.
do we add or subtract?
Subtract.
Signs are different, right? We got to subtract to get a 6 and then choose the sign of the greater absolute value. Should have gotten a negative 6. Does that make sense? All right, let's come back to you for redemption. Then on number 14, you may or may not need to change your answer. I'm not sure. What do you get for number 14 when you add the inverse?
5.
That it should be a positive 5. How about number 15? What do we get there, Lexi?
Negative 4.
Negative 4 when we change it to negative 6 plus a positive 2. And then what about number 16? 5 minus the positive 4. Evie?
Positive 1.
A positive 1 when we change it to 5 plus the negative 4. All right, before we go on, I want to make sure we've got it now. Michael, we had a little trouble on that 1. How many got 4 for 4? You got them all. Okay. Was that just the 1 that you missed? You got the other 3 right, or were there some other problems as well? You good on the others? Glenn, we good? Okay. Danielle? Cheesy grin tells me nothing. No, we're not good. We're not good. Okay. How many did you miss out of 4?
2.
2 out of 4. Which 2?
16 and 14.
16 and 14. Did you rewrite them as adding the inverse? Did you write it as 1 plus positive 4?
Yes.
And did you write 5 plus negative 4?
No.
Okay, so we didn't take the time to rewrite this as adding the inverse. Here, we need to remember that the 1 has technically a sign in front of it. A positive. Remember, if you don't see a sign, it's a positive. So here, the 5 is also a positive. So here, the signs are the same, so we...
So add.
You better memorize those rules. Add to get...
5.
And then we just keep the positive sign. Here, signs are...
Opposite.
So we have to... What's 5 minus 4?
Negative 1.
Well, 1. Don't worry about the sign yet. Just subtract. Okay? Then in a separate step, pick which sign you're going to keep. And we always choose the sign of the greater absolute value. Positive 1. Right. So do it in 2 steps. That's the reason it's emphasized this way. You got the green is the first thing you do. That's the big one to remember. Do we add or do we subtract? But then do we keep the sign or do we choose the greater sign? Does that make sense? Hence the reason for the slight color coding, if you can read it. Questions now on that? We feel like we're good? All right, now let's go ahead and do numbers 29 to 51, the odd. 29 to 51, the odd. As you work, change them to adding the inverse where necessary. Some of them, it's not necessary to add the inverse. Some of them, it's already there as addition. But some of them, you're going to need to change to adding the inverse. And 29 to 51. The odd. Let's see, Evie, sit straight. There we go. Look like you're about to make a mad dash out of the classroom or something. no. You have time to do Mad Dash last hour today. For 12 minutes. I know Kyla wishes she could be with you today. She'll be with you in spirit. In spirit. Jaden actually might wish she were here for the endurance run. Finished her thinking.
Oh, I'm done.
Done. Hayden's finished. With 29 to 51, the odd. Just the odd number. Good, Michael. Good, Evie. And Lexi. That's good.
Here.
Squeaky. Cease. Peace, be still.
Bring us thou out of my presence.
Ceaseth that noise. Or thither shall they be cast from yonder window. Use you to fill in the hole in the road.
Get out of school. I'll get our law things. Then I won't be able to.
Just not out of the road. All right, let's go ahead and take a look at these together. Number 21. Number 29. What did you get when you subtracted a positive 2 from a 2, Glenn? Oh, Glenn.
0.
0. You change it to 2 plus negative 2, which are inverses, which gives you 0. How about number 31 for redemption, Glenn? Oh, Glenn. Negative 1, change it to plus negative 4. You're right about adding, but keep the sign. Negative 1 plus negative 4, negative 5. All right, third tries the charm, Glenn. Number 33. Negative 5, there we go. 5 plus a negative 10. Subtract, keep the sign of the greater, gives negative 5. How about number 35, Evie? 0, change it to negative 3 plus a positive 3 to get 0. Those inverses now. They don't start as inverses, but they become inverses when you add the inverse. Number 37, Aubrey. 12 when you change it to 15 plus negative 3. Number 39, Lexi.
Negative 5.
Negative 5 when you change it to negative 20 plus positive 15. Number 41, Hayden. 4. We didn't have to change anything. It's already adding. Don't change nothing. It's already addition. We're not adding, number 43, also already addition. It's right there for us. Michael?
Negative 6.
Negative 6. Number 45, here we have to add the inverse. Danielle? How do we rewrite it?
Negative 10 plus positive 4.
Are the signs the same or different? Different, so we, to get?
Negative 6.
6, and then we're going to keep the negative sign, so negative 6. How about number 47? Let's go back to Aubrey.
0.
0, when you change it to negative 2 plus positive 2, it becomes a pair of inverses. Number 49, we don't need to change anything. Lexi?
Negative 13.
Uh-oh. We do, however, need to be careful. Michael?
Negative 17.
Negative 17 there. When we subtract 22 minus 5, gives 17, and then we're going to keep the negative sign. Back to Lexi for redemption. Again, don't need to change anything. It's a positive 7, negative 9 just gives us.
2.
Oh, keep the sign of the greater.
Oh, that's a negative 2.
Negative 2, because the negative 9 is a greater absolute value than the positive 7. So negative 2 should have been our answer there. Was anyone perfect on all the ones you did? I get a few of you questions on those. I tried to talk through them as we went through, but any questions? You say, can you explain how you do that one? Yes. Was that a hand or no?
Yes.
Okay.
39.
Number 39. So we have, it says negative 20 minus negative 15. I'm like, no. Plus positive 15, right? And now the signs are different. We subtract. 20 minus 15 is 5. And we keep the sign of the greater absolute value, which is the negative. It wins out, so negative 5. Literally that easy. Quickly add inverse when necessary. Right back to those sign number rules we used yesterday. Let's go back into the evens now. Okay, we did the odds. Some of us made some mistakes. That's okay as long as we learn from them. Let's hit 30 to 52, the even. $30 to 52, the even. Tell you what, I'll put the poster back up for the video students since I wait for y'all to finish anyway. I feel like a good person now, instead of a lazy person. Actually, I could use cool little magnets to hold the bottom down. Yeah, I'm too weak, never mind. Can't use cool magnets. They're boring magnets. Boring but effective. Lexi's foot down. Hayden's finished. You love your pre-algebra notes. That's touching. Really is. An upside down smiley face like a distress signal. Like upside down flag is a distress signal. Like all the Republicans did after the election. They'll put their flags upside down. Oh, we should probably not be political here. I shouldn't say it's just Republicans. All Americans who loved this country, held its values at their core. Those who had discernment and insight. For sake of time, pencils down. Even if you're not finished, let's take a look at these together. And number 30, Danielle, what did you get?
Positive 4.
Positive 4. Number 32, Michael.
That was a negative 2.
Negative 2. Number 34, Hayden.
Negative 1.
Negative 1. We didn't need to change anything there because there's already a positive 4, negative 5. Addition is assumed if there's no parentheses present. Number 36, Aubrey.
Negative 3.
Negative 3. Again, didn't need to change anything. Number 38, we did need to change a little something. Lexi?
Negative 22.
Negative 22. Number 40, back to just regular stuff. Glenn?
Positive 4.
Uh-oh, keep the sign of the greater. -4. The greater is the -7, so keep its sign versus the +3. Number 42, back to Glenn for redemption. +8. Number 44, Glenn. Number 44.
Positive. No, it's somebody. Sorry. -1.
Oh, Glenn.
+1.
Are the signs the same or different?
Different.
So we add or subtract
Sure.
to get 1. And then which sign do we keep, the positive or the negative?
Positive.
+1. Number 46, Glenn.
13.
+13. Number 48, Evie.
0.
Uh-oh, are those actually inverses?
Yes.
-8 and -8?
Well, you have to make it a positive.
Oh, okay, I see where you're going with this. All right, so Evie, if there's no parentheses, I assume it's -8 and then more, a -8 again. You could read this as -8 minus 8, but if you read it as -8 minus 8, what sign technically does the 8 have then?
Positive.
It would technically have a positive, and then when you add the inverse, you go right back to the -8, -8. Does that make sense? So should have had -16. There we go. What about number 50, Evie? -18. And the number 52, Evie? 19 is correct. Was anyone perfect on all 12 of these? You went 12 for 12. How about 11 for 12? Just missed 1. Good. 10 out of 12, just missed 2. Questions on these? Questions? Look across the page, page 109. I want you to do numbers 9 through 16, but don't use the whole number line stuff. Just do numbers 9 through 16 at the top of page 109. All right, let's go and take a look at these together. And number 9, it says -3 minus -5. I'm going to write, class.
-3 plus -5.
Ooh.
Positive.
-3 plus +5. But remember, I said I'm too lazy to write plus +5 normally. Normally, I would just write -3
Plus 5.
+5. Not plus, positive. And signs are different. Subtract, we get, class.
2. Positive 2.
+2. Keep the sign of the greater absolute value. On the next one, I'm going to write this as 3 plus -6. So I'm just going to write +3, -6, or 3, -6. Signs are different.
-3.
3, keep the negative because the negative is greater. How many at -3? On the next one, -9 plus
-4.
-4, but I'm too lazy to write the plus. I'm just writing -9, -4. Signs are obviously the same, I get.
-13.
Add and keep the sign, -13 on the next one, 9 plus,
-8.
or in other words, 9, -8, or you could say +9, -8. Signs are different.
1.
1, and keep the positive 1. Number 13, 9 minus -6. No, 9 plus +6. 9 +6?
15.
15. On the next one, -6 minus -3? No, -6 plus
Positive.
+3, or just -6 +3 gives
-3.
-3. By the way, it's the same as this one, but instead of +3, -6, commutative property, -6 +3, same answer. Number 15, instead of 16 minus +5,
16 plus -5.
16 plus -5, or 16 -5 gives +11. On the next one, 5 minus positive 7 becomes 5 plus negative 7, or 5 negative 7 gives negative 2. Do you see how to write it without the parentheses? I'm a big fan of no parentheses because I am lazy. We're going to see that here in just a moment as well. Turn back to page 107, and we're going to use that commutative property to our benefit here. If we have multiple addends, meaning lots of numbers all added together at the same time, we can go out of order as long as it's all addition. And remember, it will be all addition because we never subtract with signed numbers. We add the inverse, right? As we look at this, we have a negative 2, and then it says in the yellow shaded box plus negative 5. But I'm not going to write that, class. I'm just going to write negative 5. And then it says positive 8, so I write positive 8. Then it says plus negative 9, but I'm just going to write negative 9. And then it says positive 7, so I write positive 7. Here's the best way to add a series of addends together. Get all your negatives together. Reason? If all the signs are the same, you get to just add and keep the sign, so it's super easy. What do I get when I add all my negatives?
16.
Negative 16. Addition is easy, a lot easier than subtraction. And then I'm going to get both of my positives together. Class, when I get all my positives together, I get
15.
Positive 15. And now I'm going to do one addition with unlike signs. So only one time do I actually have to subtract and choose the greater absolute value. Here I'm going to get, class, negative 1. Keep the sign of the greater absolute value. Now, you say, couldn't I just go in order, Mr. Nanaski? Sure. Negative 2, negative 5, class.
7.
Negative 7. Negative 7, positive 8.
1.
Positive 1. Positive 1, negative 9.
Positive 8.
Negative 8, keep the sign of the greater. Negative 8, positive 7. Negative 1. Same answer, but then you have to keep track of, wait, this time I'm adding because the signs are the same. This time I'm subtracting because the signs are different. That's too hard. You only have to do one of these and two of these. And you get to start with these two to get all the negatives together, get all the positives together. Seem easy enough? Do it the easy way, not the hard way. Look over at page 108 again. And look at number 53. How would I have written this problem? Because I wouldn't write it the way they wrote it, Glenn. Positive 1.
Plus negative 9.
Well, that's what they wrote, but I don't write plus negative 9. I just write, and then I write negative 8. This is how I would have written the problem. And the good news is I only have a single positive. So I'm going to get all my negatives together right off the bat, class.
19.
Negative 19. By the way, commutative property, 2 and 8 is 10,
Yeah.
and 9 is 19, right? So negative 19 is easy. And then we only have the single positive to put with it. Now, once and only once do we have to mess with different signs.
Negative 18.
Negative 18. Do you see how to do 53? Look at 55 right below it. How would I write this problem down, Aubrey?
Negative 20 plus 7.
Not plus 7, positive 7.
Positive 7. Negative 17. And positive 19.
There we go. I literally write down all the different numbers we have present because it's assumed addition. And here, let's get all of our negatives together first, class. Negative 37. And let's get all of our positives together.
26.
Positive 26. And now only one time do we have to subtract, keep the sign of the greater absolute value.
Negative 11.
Negative 11. There we go. Do you see how quick and easy multiple addends can be if you do it the smart way? How about number 57? Notice this time, oh bless them, it's already written the way I like it. I've got the negative 20, negative 5, positive 9, negative 3. And Danielle, we're going to first group all of our negatives together. Negative 20, negative 5, negative 3 gives
Negative 28.
negative 28. And then, Danielle, we're going to get all our positives together, but there's only one. Positive 9. And then one time we subtract, keep the sign of the greater absolute value, class. Negative 19. Subtract get 19, but keep the negative because it's the greater absolute value. Uh-oh, look at 59. We got a problem here. Do you see how it has a subtraction? Oh, fix it. Make it adding the inverse. Do you see it as the fourth number in there? It says minus
And
negative 3. Change it to adding a positive 3. What's the problem?
And the 15 minus 8.
That's not a 15 minus 8. That's a positive 15, negative 8.
Oh.
Yep. It's only a subtraction if it comes before parentheses. Otherwise, you assume it means negative. But if it's before parentheses, it clearly is not a negative sign, but a subtraction sign. So there's one subtraction, we're going to change it to adding a positive. Now, let's go through and do it without any parentheses, Hayden.
15, -8, -3, positive 3, -5.
Perfect, and perfectly read, good. All right. Wait, what?
Never.
Okay, all right. By the way, I can speed up my work a little bit. That's not an equal sign, that's a very bad negative sign that came twice. I can speed up my work a bit because do you see the inverses, class?
0.
I'm not even going to mess with the inverse, I'm knocking them out. Now the problem becomes that much easier. I've only got one positive, but I've got a couple of negatives.
13.
Negative 13, put it with a positive 15, you get? Positive 2. Do you see how to work these problems? Do 54 to 60 to even. For sake of time, pencils down even if you're not finished. I went through and I rewrote each of these without all the little parenthesis nonsense. Now, there was a minus negative 21 here. So when I wrote it down, I put, it would have been plus a positive 21, so I just wrote the positive 21. And there was a minus negative 16 here, which I changed to plus a positive 16. Okay, but otherwise, we just go, right? Get all your positives together, class?
Well, the bottom one's not 16.
It's not
it's
16,
6.
it's 6.
That's a 6? Oh, let's try 6, thank you. All right, we're good now? All right, so with the top one, class, we get our positives together.
11. 7.
Positive 7. We get our negatives together.
14.
Negative 14. Now we subtract, keep the sign of the greater.
Negative 7.
Negative 7. For the next one, I only have one negative, but I get all the positives together.
41.
Positive 41. And I put that with a negative 33.
Positive 8.
Positive 8. Should have been our answer. For the next one, I've got a lot of positives. By the way, I get these two together first.
34.
And then
34.
34. And I've only got the one negative.
32.
Positive 32. Or we could just say 32. And then on the last one, I've got, stay with me, a negative and another negative. Negative 9. And then I've got a few positives.
25.
Positive 25. Put the positive 25 with the negative 9.
Positive
16.
Positive 16. Didn't even go 4 for 4.
That's where you got the 16 from, because that 16 is the answer.
You know what, that may have been it, because I do have the answers in my book, so I may have been looking at the blue number at the end. How many got 4 for 4? Anyone get just the first 3 done, but you went 3 for 3 on them? Maybe just didn't finish? All right, questions on this? For homework this evening, I want you to do page 109, numbers 22 to 37. Page 109, numbers 22 through 37. All right, you are dismissed.